Mr. Lee works in Hyundai since 2009. In 2016, he got a master's degree in electronics, attending the ELS Embedded Lighting System training. Today, he is principal engineer in the Advanced Lamp Research team in Hyundai Mobis. Mr. Lee, the floor is yours.
잠깐 나갔다 올게요. 플라스틱 없는 일을 좀 조금.
Yeah, good morning. My name is Lee from 현대모비스, and today I'm gonna tell you about my study, which is slim and dual optical system for next generation of headlamps. So there are three key points here: slim and dual. Lastly, next generation. So slim means the trend is slim in nowadays, and also dual means it's low beam and DLL. So finally, next generation. It will discuss at the last part of my presentation. So please keep focusing on your attention on my presentation. Yeah, here we have some contents, the intro, development, and result, and conclusion and forecast. So behind the contents, you can see the teaser image of Genesis G80 headlamps. So your center parts, there are DRL, and the other parts are low beam. So if you imagine the low beam and DRL were performed by one module, then this image is quite different from now. So that is my originate idea for my study. So as soon as you can see these photos, you know well very much about the name of car and which function. So because of brand signature, that's why you know the certain car's name or certain function easily. It means designer really want to show their brand signature by headlamps, especially DRL function. So do you think about why they use a DRL function? I think DRL function, beam pattern of DRL is quite simple to make it, and there are so many freedom to make a design. That's why they use a DRL. That's what I think. So we can think about the beam pattern in detail here. We have a low beam pattern and DRL pattern. So the low beam pattern has a cutoff line. So that's why we want to make a low beam. We need a shield or something else to cut off the line. That's why if we make a both beam pattern by using one module, that's very difficult. If you want to make it, you need to use actuator or moving shield and so on, or to separate the function. So, but designer wants show their brand signature as a low beam and also DLL. But as I mentioned already, that's very difficult to perform by one module. So they want to make a pretend module. What is this meaning? Is that we put the sub LED instead of beside of low beam light source. Then it works for DLL, but it's not a real DLL. We need a dedicated DLL module to perform the DRL regulation. Because of that, the lead image is quite different from both of images. The low beam is full of the lens, but DRL is quite different from low beam lead image. That's why the design is quite different, both of them. So now I can suggest new solution to perform low beam and DLL by using one module. So at the left photo, you can see the normal type projection system. It's It consists of a spherical lens and shield reflector LED. You know very well. So from this idea, I can develop a new concept, which is prismatic optical system. Let's think about that. The spherical lens and shield will be made by one parts by using a plastic lens. So this is that. I call it the prismatic lens. So and then you know this is those are collimator. This collimator for lobing and this collimator for DLL. Then you can use both functions by using only this module. So you can follow the red line, then it works for lobing. And you can follow blue lines, then you can use a DLL function. So please think about the part here is for lobing and the others for lobing, DLL and lobing. So in this page, we think about the light intensity. So the main purpose of that, the lead image is exactly same at both functions. So you can see that this intensity density analysis. So you can use a full white lens. Actually, these results are from the simulation in front view of this lead module. So white means it's lit on all surface of the whole exit surface. So we cannot see the difference from both images. But we use a higher resolution, then we know the definitely designated area for each function. Here is for the DLL and the other area for the lobing. So the surfaces are defined separately for their roles to meet the regulation, but the image is almost same. That's the key point of this module. And the next stage, we think about some side effect of this kind of optical system. So we use a PMMA material to make this lens because we want to avoid color dispersion. So that's why we use PMMA material. But in this case, the PMMA material is very weak to the thermal effect. That's why some burning was occurred because of the material thermal characteristic. So, here there is one hot spot. That's why the thermal is focusing on that one point because to make a hot zone of the beam pattern. So at this point, that is very weakness point of the lens. So, and also we needed to block below this point to make a cutoff line. So if you put a coating or any other structure on this area, then the thermal temperature is going higher and higher because of that material. That's why we need to avoid those kind of situations. We make some total internal reflection angle to here. Then we can remove the coating or any other mechanical structure at that point. In case we can get a positive result. So here, actually, when we put a coating, then it has a burning point. So we can lead out the coating instead of then we put the TIR structure instead of coating. Then we can see any defects here. next one is chromatic aberration. This means color dispersion. So it's the schema of the prism lens, as I mentioned before. So in this case, we use a normal splitter type of collimator. Then it occurs some color dispersion at the edge of the collimator. So it makes this kind of color dispersion. So we cannot use those kind of beam pattern. Nobody wants those kind of color dispersion. So we need to improve the color uniformity. That's why we can change the collimator shape. So in this collimator, the edge surface is almost flat, so there is no color dispersion as before. And also we can make a color mixing inside of the prismatic lens. So in this case, there are color mixing before the projection. So we can get this kind of good color or beam pattern. So I can suggest two different design solutions by using prismatic lens module. So in this case, you can see the line image, and then the other solution is dot image. There are some gaps between the lenses, so it depends on your requirements. Right? In each case, you need some modules. In this case, 8 or 7, and the others are if you need, you can use as a reference. Then the total flux is almost similar, but important thing is that this module is 25 millimeter height opening, and the other one is 12 millimeter height. So it's a little bit different design. Yeah, now you can see the performance of those optical module. So it's the beam pattern and almost over 30,000 candela and 750 to 60 lumen, and the power distance is 138 and width is 40.5 meter for with 3 lux line. So you can see the real sample of two mock-up modules. So this is 25, this is 12 millimeter prismatic lens. So actually, those are same concept, but it depends on the lens location. So the lens is put on the axis surface. In this case, the lens is put on the entering surface. Then there are drift angle here. So that's why there are two different design can be operated. And also the entering surface size is quite big gap. So because of the drift angle, it depends on the lens location. So if you use this lens, in this case, the entering surface is quite low. That's why it has it needs more number of modules to perform the low beam and DLL. So before I said we need an 8 module with a 25. We need a 7 module with a 12 millimeter. So you can see turn-off module image for with line image prismatic lens and light on. Which one is DRL? You can do you distinguish of it? Yeah, this one is DRL and this is low beam. DRL and low beam. I just changed the shutter opening time, but almost the same image, both of functions. For the last, I want to suggest one more thing with this module. So, as I said, we can use the low beam and DRL by using this module, but if you put one more LED for turn indicator, then it will be works for tri-function, DRL, turn indicator, and low beam. So it has, yeah, it's the schema of that concept. You put the DRL, LED, and collimator, and turn LED and collimator. That's enough, and then you can use a DRL and turn indicator and low beam. Yeah, here I have some photos about the turn indicator. You can see turn indicator and low beam with a turn indicator. I don't know why it is blue. It is definitely white because it is low beam, and this module is low beam and turn indicator. In this case, in terms of safety perspection, there are some weakness points. When we see this module at the downside view, sometimes this color is a little bit strange because of both functions are mixed, turn and low beam. Because low beam and DRL is the beta function, so it never works at the same time. But sometimes turn indicator will be work with the low beam, definitely. That's why the color mixing is happen at the certain angle of the view. So I think that's the problem. So for the safety perspection, some customers need a dedicated function for the turn indicator. So I think if we use a dedicated function for turn indicator, then we can use this tri-function module. So I think I suggest only use this module, then you can realize your headlamp instead of a whole system of headlamp, low beam, DRL, and turn indicator, and also position light. So it is very small and it works for all headlamp functions. Then there are so many space in your headlamp. So I think you conceive this space as a LiDAR or radar, which is ADAS sensor. So in this case, you can use any freedom of your headlamp. So thank you for your attention.